All right, so welcome everyone to the very best from the Visible Green Home Tour Series. We're going to be looking at several small videos of specific features of green building, of aspects of green building from the start to the finish of homes across four different projects with one of our longtime friends here at GHI who I'll introduce briefly, and then giving some extra context to each of those, and then expanding on how they all connect and work together to make our homes more sustainable and better. So please stick around for that. And before we get started, I just want to say a huge thanks to all of our sponsors who allow us to do what we do and to make to design our homes more sustainable and to give us the products that help us achieve sustainability goals and decarbonization and lower utility bills. So make sure to check them out on our sponsorship page. So again, with that, welcome to our session here, the very best from the Visible Green Home Tour Series. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. This course, like all of our courses, is approved for multiple continuing education units. And in this case, we're approved for all five of the pillars of green in our certified green home professional training, as well as AIA health, welfare, and safety, which may make it applicable to your state-based design or contractor license. Make sure you grab that 5-digit passive house code that will come up at the end within your certificate, as long as you're here for the entire CEU approved hour. So with that, I'm really excited to get started and welcome our speaker, Michael Clement with Architectural Resources. And Michael is no stranger, actually. He's been involved with our organization before I even came on the scene. He's been a
Don't
member
don't
here.
don't date me, Brad. Don't.
uh, and so it's just incredible to see, and to continue to work with Michael and his team and what they've done. And he's no stranger to our trainings. You've been on several, I think, of our net zero conferences and involved in those. And so I think this is the first time we have you here as a whole spotlight on what you've been doing. So welcome, and please take it away.
Absolutely, Brett. Thank you. Yes, and it's exciting to see what you have done, sir, with the Green Home Institute. I'm so excited to be with you all today to share with you, as Brett mentioned, four high performance homes, two of them passive houses, one of them a LEED Platinum home, and the fourth a home that is certified in the DOE Net Zero Energy Ready program. So what we're going to do, I should probably introduce myself. Michael Clement, Principal of Architectural Resource. We are a sustainable focused residential design firm based in Ann Arbor, Michigan, but actually doing projects across the country. And I'm really excited today to not only present to you myself, but I have our entire team with me because we are a team. Everything that we do as a group entity. And I'm going to have them introduce themselves one at a time. And then they're going to be answering questions in the chat, and they'll stick around after to answer questions as well. First, let me introduce our most senior tenured uh, outstanding colleague, Susan Hall.
Hello, everyone. I'm Susan Hall. I'm a certified passive house consultant and a certified aging in place specialist. As Michael said, I've been with the architectural resource for quite a while. It's going on 13 years. And during that time, I've had the honor of being project designer, working alongside Michael with projects from Living Building Challenge projects to LEED projects, LEED certified projects, passive house projects, and DOE net zero energy ready homes. So very excited to be here and welcome to all of you.
Thank you, Susan. Next up in order of seniority is Dale Babcock.
Hello, everyone. Dale Babcock, also a certified passive house consultant and certified aging in place specialist. I've been with Architectural Resource going on 11 years now. And during that time, I've had the opportunity to work on a multitude of green homes, high performance homes, healthy homes. The most recent of which was a gut remodel and second floor addition to an existing 1,100 square foot ranch that is targeting the DOE Net Zero Energy Ready program.
Excellent. Yeah, and that project is actually going to be potentially on tour this coming fall through the Builders and Remodelers Association of Greater Ann Arbor. Next up is Alex Jackson.
Hi guys, I'm Alex. I am also a certified passive house consultant and aging in place specialist. And my passion is beautiful, affordable, sustainable homes. So I get to do that, or I've gotten to do that over the last 9 years with Architectural Resource, with projects, homes across the country. We've got a Living Building Challenge home in construction now. We've done a couple of passive houses in Indiana and Michigan, and some LEED Platinum homes in there too. So happy to be here today.
Yes, and the project that Alex is mentioning, the home in Jackson, or pardon me, Kalamazoo, Michigan, Living Building Challenge candidate will be potentially having that on tour this coming winter, spring, and summer through the Visible Green Home Tour. So excited to share that with everyone. Thank you, Alex. And last but not least, our newest colleague, the newest project designer, Trevor Worthman.
Hello, everyone. Yeah, I'm Trevor Worthman, as Michael mentioned, the newest member, the fresh face here. I've been with the company about 3 years by way of the enhanced intern program as I finished my education at Lawrence Tech in Southfield, Michigan. And yeah, this is really special for me. I was connected to this office by way of a kind of student-centered visible green home tour and was just so taken by everything that this office does and got connected and have worked with them through the internship program and having just completed my master's in the summer, stepped up into the project designer role and am happy to say I'm now enrolled in the CPHC training myself. So we'll be joining the ranks of the all CPHC certified staff we've got going here.
Trevor, we're thrilled to have you with us. Thank you so much. All right. So what we're going to do now is jump into these 4 vignettes, beginning with Gabriella's Green Villa. This is a passive house that we completed in Manchester, Michigan. And we're going to start out with the basics, and that has to do with the control layers in a building.
One of the really special things about our Visible Green Home Tour series is we give you an opportunity to look behind the curtain and see basically the layers of the onion that make a high-performance home. In this case, we're literally going to be able to see the layers of the onion. We know that there are 4 layers in a high-performance wall: a bulk water control layer, an air control layer, a vapor control layer, and a thermal control layer. Every high-performance wall has those elements, and they need to be considered in that order, in that sequence. This zip sheathing is providing 3 of those 4 critical elements. It is our continuous air control layer. And if you notice, all of the seams have been taped. That makes it one continuous control zone so that no air moves through the wall. That's critical in terms of controlling for convective energy movement. This is also providing our vapor control layer and our weather control layer. Outside of that, we have the first layer of our thermal control layer. This is polyisocyanurate insulation, paper-faced, 1.5 inches thick. On top of that is placed another layer of the onion which is a 2-inch polyisocyanurate insulation layer. And all of the seams have been offset and staggered, again to try to create a very tortured path for air to move through this assembly, hence increasing its performance. And lastly is the furring strips. These furring strips are going to provide the substrate for the siding attachment. When the siding goes on, there's going to be a 3/4 inch airspace between. That allows water to track not only down the face of the siding, but also down the back. This creates a ventilation air chamber that allows this to dry to the outside as well as to the inside. This is what we consider a high performance wall using continuous exterior insulation.
And what was kind of a revelation for us in our office is when we learned through Building Science Corporation, Joe Stiebrick, about these 4 layers. We actually went as an office to his building science fundamentals training in Boston. And we always think about our value as being the be all end all. As it turns out, it's the last thing on the list. Air control, bulk water, obviously, and vapor come beforehand. So that was really, for us, kind of a revelation. I'm going to jump over to a different video now, when we're going to be talking about water control and how we manage the water control for this home. Because I've always learned that it's water 1 and architectural resource 0.
We're down now at the business end of a high-performance wall, and that's where the wall meets the foundation. Down, out, and away is what we want to think about in terms of controlling bulk water movement. What we're using here is something called CuraVent. CuraVent is essentially corrugated cardboard made out of plastic. This provides a fastening substrate for the starter course of our siding, and it planes out because it's 3/4 inches thick with our furring strips. That sits on the outside plane of the exterior-most polyisocyanurate, and then it lands on top of what we call through-wall flashing. This is a metal flashing that's held back against the face of the zip sheathing, which is our primary water control layer. We tape that, and then that is continued outward, down, and creates what's called a drip. This prevents water from wicking back to the foundation and instead drips away. I've learned over my career that water always wins, and if you take that into account, you design your wall to fail safe. That's what we do at Architectural Resource.
I have an alarm going off in the background, of course. It would happen during this presentation. But this idea about failing safe and really understanding that water always wins drives, frankly, a lot of what we do. In fact, most of what we do at Architectural Resource is to control water. Everything else is kind of subordinate to that. This next segment is going to talk about what we call design effectiveness, as we try to do more than one thing with every design decision.
We have a great opportunity with Gabriella's Green Villa to do what we like to do at Architectural Resource, and that's have one design solution solve multiple issues. This home is sitting in the middle of an estuary. We had very hydric soils, high groundwater, and we knew we weren't going to be able to do deep footings here. So what we did instead is use something called a floating mat foundation.
Lost your sound, Michael.
We like to do at Architectural Resource, and that's have one design solution solve multiple issues. This home is sitting in the middle of an estuary. We had very hydric soils, high groundwater, and we knew we weren't going to be able to do deep footings here. So what we did instead is use something called a floating mat foundation. What we did is we excavated and provided a 4 to 6 inch layer of crushed stone underneath the house. Then on top of that, we place multiple layers of expanded polystyrene foam. They, on an aggregate with a 3-layer build, generated roughly 12 inches thick of insulation, basically an R50 foundation insulation. That same insulation was brought around the perimeter footing and up the exterior wall, as you can see here. That created an isolated mat, which is what's called a frost-protected shallow foundation. So we didn't need to excavate deep and get into the high groundwater or the questionable soils. We basically stayed above that. The other thing that this solution did is provided a heat sink, basically a thermal battery, to collect this beautiful radiant solar energy coming in from the south, streaming in through the windows, landing on the floor, and being sucked up, absorbed into that concrete, so that long after the sun is down, that heat energy will be radiating back into the home. That's what we call smart design.
So the smart design concept is all about being able to find multiple solutions from one design solution. And in this case, we had several things going on. Several things going on. We had a site that had these hydric soils, high groundwater. So there was this confluence of influences that were pointing us towards this direction, and it worked out beautifully. We had used a product called Warm Form on a previous project, on the 713 project. You can learn about that if you go to our architectural resource website page and check out some of the other visible green home tours. But what we did here is we said, well, we could buy this stuff or we could make it. So we ended up making it out of these large blocks of EPS. So next up in our kind of roster of high performance is the high performance windows. And we're going to share what we did here with you now.
Now I'd like to show you how we install windows in a high performance home. We're inside Gabriella's green villa at the rough framing stage. Behind me is a passive house window. This has 3 layers of glass providing 2 chambers to control energy movement across the window, as well as a thermally broken sash. If you've ever had a chance to open or close a passive house window, you know this is a window. This window is installed using clips. Why is that? Typical domestic windows come with what's called a nailing flange, and that's an extrusion around the perimeter of the window that allow the window to attach to the outside face of the home. In a passive home, because of our high performance design, we really want that window plane to be in the center of the thermal profile for the wall. These clips allow us to fine-tune the location of that window in the assembly. Once the window's installed, we have a shim space that runs around that, which is basically 1/2 to 3/8 to 1/4 inch of space, allowing the windows to be put in plumb, square, and true. But that's a space that energy is going to be moving through that window, convective energy movement. So what we're doing in this case is using something called expanding tape. This is how it comes from the manufacturer, and you can see it's a very thin profile. It's compressed. What happens is the window is surrounded with a perimeter of this foam tape, and then it's set into place, and then several days later, the foam expands to fill that gap. This provides a continuity of the air and vapor control layer at the high performance window.
And this Hano tape, Hano is a brand. There may be others, but we've used this. We can get this from 475. What's nice about it is it allows you to get the window set square, true, plumb, and then you install this tape and it fills the gaps. We've seen it do amazing things in terms of filling gaps. You do have to be careful using this product. Our builder colleague, Mike Mahon from Adaptive Building Solutions, discovered that you want to have a cooler chest on site, and you put some ice blocks in there and put the tape in there. That keeps it cool, because when it gets hot, this stuff expands much faster than you might want it to do otherwise. But this has really been a revelation for us in terms of how we would close off those gaps around windows. Let's see here.
This house has no basement. We are using a floating mat slab on grade. The issue is many of our clients, myself included, have stuff and we need places to store stuff. I'm in currently what's going to become the future basement, quote unquote. It's a storage area on the second floor of Gabriella's green villa. Above me are the trusses that form the roof assembly. And as you can look behind me to my left, you'll see the heel height. What's the heel height? The heel height is the dimension from the bottom of the truss to the underside of the roof sheathing. You'll notice that it's quite deep. We have a 30-inch insulation blanket that's going to go across the entire attic of this house. And so we needed to have a higher heel height to provide that adequate insulation level. This is key. In a passive house, we really think about the insulation as being continuous and uninterrupted. And that's how we create the high-performance home using 80 to 90% less energy than a conventional home.
Yeah, this idea of the heel and how much space you need, this is a challenge because in some houses, like the opportunity in terms of the design to really have a 30-inch heel makes it a little bit of a challenge. In this house in particular, which was a simple Cape Cod slab on grade, we didn't have a basement. And in fact, on some of our passive houses where we don't do basements, we still have this storage concern. And so what we're doing is we're basically bringing the basement up out of the ground and adding it to the roof. Let me close this. And I'm going to open up, I'm going to try to open up. There we go. And let's close this. It's in Birmingham, Michigan. And it was, I believe, it was the first design certified FIAS Plus 21 zero home. We are deploying on this a double stud wall, but not your typical double stud wall. What we're using is the guidance from Building Science Corporation, where we're actually putting the air control layer and structural sheathing outboard of the interior wall. I'm going to start this and then we can say more about it once it's rolled through.
So we have an opportunity here with this mock-up to explain to you this high-performing double stud wall assembly. This is perhaps one of the most resilient, robust, passive house enclosure envelopes we've ever designed. This mock-up is showing you what's on the inside of the exterior wall. So this is the floor framing, and we're showing the floor deck. Then we have a sill plate, a window opening, header, the double top plate, the second floor assembly, all the way up to the top plate, and then this is showing what's going to be up at the ceiling. So this is a compressed version of the actual wall. On the inside of this house, it's built pretty much like a conventional home. We've got 2x4 framing, we've got 3.5-inch wall insulation, we've got wood eye joist. Everything is pretty much the same. This wall, the interior wall, becomes our load-bearing and structural wall. What's really exciting about this is what goes on the other side of this assembly, where we're going to talk about the double stud assembly to the exterior.
So This project, again, as we mentioned, was one of the most forgiving, resilient, high performance walls we've ever constructed. The whole idea of double stud wall is kind of in the news of late. A lot of folks are doing double stud walls. This one was our first foray into it, and we wanted to be very conservative about how we were managing moisture. And the folks at FIAS love this assembly, particularly the next thing I'm going to show you, which is the exterior component of this wall.
We're on the exterior surface of the wall that we had shown you previously, which is basically built as a conventional wall. 2x4 framing behind this green sheet. This green sheet is something called zip sheathing. In conventional construction, this would be considered the outermost layer of the wall. In this wall, this is actually the inner layer of the wall. It's in the center of the wall with a 2x4 frame wall beyond it and a secondary 2x4 framed wall in front of it. This is why this is referred to as a double stud wall. We have the structural sheathing, the structural framing, everything behind this is conventional, and then to the outside of that, we're building a secondary stud framed wall, which is going to allow an 8-inch cavity to be filled with insulation. There's going to be a 4.5-inch space here and a 3.5-inch space here. And by setting the framing off of the exterior sheathing, we get the thermal bridge break that's going to help us reduce our energy transfer through the building. One of the things you're noticing here is the tape. Because this green area is our air control layer, all gaps and seams need to be taped. This is a small version of what would be a much larger window opening. What we've done is created a rough buck. This is a 3/4-inch plywood enclosure that's attached back to the structural wall. It reaches forward, and as you can see, the tape is brought forward and wrapped back in where it will engage with the window, making a continuity of the air control layer. This then will have an additional layer on the outside of something called Den's element, which we'll talk about when we take you to the outside. And then mounted to the top of that is going to be a drainage matrix called Home Slicker that's going to provide a 1/4-inch gap. So when we put our siding on the top of this, any water that gets behind the siding is able to drain down, out, and away. This is perhaps one of the most resilient, durable, high-performing walls we've ever designed. And it's really exciting to share this with you.
So we're going to go outside now and take a look at that Den's element product, which is key to this wall's performance.
When we design a high-performance building enclosure, we go about everything we can do to make sure we're managing the water and keeping it out of the walls, which is great until we go ahead and put holes in the walls and call them doors and windows and ask them to carry forward that same level of rigor. One of the things you'll note here is at the top of this window, there is something we call drip flashing. This is a piece of that flashing that's already been installed. That will take any water that lands on top of the window and direct it down, out, and away. And you see how that's been incorporated into the weather-resistant barrier with the liquid flashing. This weather-resistant barrier is called Den's element. Den's element is a really special material in that it combines the functions of the WRB with the functions of the air barrier in one product, one installation. This eliminates the need for a separate application and saving multiple trips around the house. The really exciting thing is that for this high performance, high R value wall, we have to pay particular close attention to moisture management because we've radically reduced the energy flux across the wall and thus reduced the drying potential. Den's element has an insanely high perm rating of 30 as compared to a typical OSB sheathing with a perm rating of around 2. Perm rating is a measure of the ability of a material to pass vapor moisture. The higher the perm rating, the greater the ability to pass moisture. This is a super high R value, high performing wall that can dry inward through the drywall, but also dry outward through the Den's element, leading to a super durable wall.
But wait, there's more. We also have concerns for water that might get into the window assembly and need to find its way out. If you look underneath this sill, you'll see that there's more metal flashing doing the same exact thing that's happening at the head. This metal flashing goes back under the window to create what's called a sill pan. So this way we have our first line of defense at the head, and then if any water happens to get into the window opening, it has a chance to come out. This allows us to take an extreme level of moisture management to this building, making it highly durable
And highly sustainable.
And that Den's element is a product that we've actually designed a simpler double stud wall, which is basically 2 studs, interior and exterior. And we worked with Graham Wright at the FIAS Passive House US Institute, and we did hydrothermal analysis. And I know that many people are very comfortable with just running drywall on the inside and OSB on the outside and doing a 12-inch spacing double stud, which can work if you're meticulous about your air control and vapor control. But we designed a project that we call the 2 Horses Project, which is the intention is to make this passive house performance easier to achieve by mere humans. And to do that, we were finding that this Den's element really works because it's so insanely vapor open on the outside that we can do a conventional double stud and not have to be too concerned about having extreme levels of performance in terms of airtightness.
Here we're on the exterior surface of the Pleasant Future Vision Passive House. This is something that's called Home Slicker. What this does is allow us to attach our siding and provide a 3-dimensional drainage and air ventilation matrix behind it. This then brings it down to flashing, which again, much as what we had done at the window at the sill and at the window at the head, that idea of controlling the water past this exterior surface out to the exterior of the surfacing on the foundation. Down, out, and away is a strategy that we carry all the way down to the grade.
And what's nice about that is it allows a 3-dimensional matrix for the air and water to move through. Let's take a look at the foundation.
We're now down in the basement of the Pleasant Future Vision Passive House, and I'm going to share with you how we've designed the wall assembly, the foundation wall. Many people think about roof and above grade walls, but the below grade walls are actually an important component of a high performance building as well. In this case, we're using something called ICF, or insulated concrete form. What it is a 10-inch concrete core with 2.5 inches of expanded polystyrene insulation on the exterior of that. We are also, in this case, putting a 2-inch layer of board insulation to the exterior of that, that's serving both a R value enhancing purpose as well as acting as a drainage mat to allow water that comes to the foundation to run down the foundation face, exterior of the waterproofing, which is mounted to the outside of the ICF. And then inboard of that, we have a stud frame wall cavity that's held off of the ICF that's also going to be insulated. All told, the R value of this foundation wall assembly is going to be R48. Code is R10. So again, as you can see, there's a significant difference in terms of maintaining the energy in a home, both above grade at the roof and down below grade as well.
And while we're in the lower level, we're going to go ahead and take a look at the slab condition. And this was a particularly challenging slab condition because we had a high groundwater.
We're in the basement of the Pleasant Future Vision Passive House, and we want to talk about the slab. We know how important the roof is, the lid. We know how important the exterior walls are above grade. We've talked about the below grade walls. Here's an opportunity to talk about the slab, that part that meets the soil. In this case, we have a 4-inch concrete slab that has a polyethylene vapor control and air control layer underneath it that's continuous. Beneath that, we have 2 layers of insulation, a 2-inch rigid insulation layer and an 1.5-inch layer. Those 2 layers with offset and staggered seams create a thermal break that gives us an R value of 17.5. Code only asks for R10. So we're dialing up the energy performance in the underslab condition. This house has 2 other layers which are key to the performance, and that is a 12-inch layer of pea stone and a 12-inch layer of 6A rock. Those 2 layers are helping us defeat any type of groundwater that may be coming up from below, because we have water that comes from the heavens in terms of rain, we have wind-driven rain, but we also have soil water that would come up.
And while we're looking at the envelope, let's go ahead and take a look at the final piece of the envelope for this project, and that is the lid.
We're up at the 2nd floor of the Pleasant Future Vision Passive House, and we can share with you how we're managing the lid. The lid is the top of a building, which is very important in terms of convective energy management. Warm air rises, and as diligent as we need to be with penetrations in the air management layer in the walls, we need to be doubly diligent up here at the ceiling and the lid. If you look above me, what you'll notice is there's that same zip sheathing that we had used for our air management layer in the walls. In this case, it's turned flat. It's attached to the underside of our truss framing system, and all of the seams are taped, all the penetrations are sealed, and the idea is to create a super rigorous air management layer, in particular at the lid. Above that, we have cellulose insulation, which is giving us an R110 compared to code minimum, which is 38. So as you can see, there's quite a bit of difference in terms of performance from a standard code minimum to a passive house high performance. So once we have the zip air and vapor control layer underneath the trusses, then we install the interior partitions. This is a little bit out of sequence because what typically happens is the trusses are in place, the interior partitions go up, and then comes the drywall. In this case, we are closing off the air and vapor control with the zip sheathing and then putting the service cavity underneath that, allowing drywall to go to the top of the partition, as you can see here. So we have a really robust building envelope all the way through from bottom to top. As the saying goes, a high performance house needs a good pair of boots and a good hat.
And I'm kind of zipping through these at a pretty good clip because we had that little bit of an interruption. But we're going to take a look at the ventilation strategy next. And here.
You've probably heard the old mantra, a house needs to breathe. Well, actually, a house doesn't need to breathe. People need to breathe. And in most cases, our houses are not only breathing, they're hyperventilating. The DOE would say that most of our homes built conventionally have the equivalent of a 24-inch by 24-inch hole that's allowing inside air that you paid to heat, filter, condition, leave, and then unconditioned air from the outside come in. Behind me, you'll notice these gray corrugated pipes. These are part of our high-performance ventilation system because in a passive house, we take a mantra which is build it tight and ventilate right. What we do is we use an ERV, an energy recovery ventilator, that extracts humid, stale air out of spaces such as bathrooms, laundry areas, kitchens, and we exit that to the outside of the building. We bring in fresh air, and we're able, through the energy recovery ventilator, to recover the heat and humidity from the outgoing air. So let's say it's the winter time and we have 0-degree temperature, 10% relative humidity air outside, and we have 70-degree and 30% RH air inside. We're able to recover some of that humidity and heat on the incoming air, upwards of 89 to 92%. That air comes into the house and is then delivered to the living spaces, bedrooms, gathering areas. In this way, we keep constant ventilation moving through the house, but we're not leaking energy. This is how we approach ventilation strategies in a high-performance passive house.
And what I'd like to do now is jump over to a different project. And Brett, thanks for sharing with me that I have to stop share and reshare. And this is a project that we did in Northville that achieved LEED Platinum certification and DOE Net Zero Energy Ready certification as well. And I'm going to get this started here. And I'm going to jump right to this. Hang on a sec. Share this or that.
We're in the front yard of the Pond Hill project, and it's an opportunity to share with you how we at Architectural Resource let the functionality and the goals of the client drive the actual design of the home. We're going to be using solar panels to generate the power to help this home become the net zero energy home that we've described. But for that to happen, we have to carefully understand the site. In this house, the south was facing the street. So that meant that we really wanted to create an armature onto which we could mount those panels. The roof of the home is very simple. In fact, it's kind of running counter to what we're seeing happening with most homes these days, where we describe them as quote unquote 5 gables to the street. In this house, we have a very simple roof form, and we have one gable. And that one gable is providing light, openness, and ventilation for the 2 guest rooms on the second floor. So here what we're looking at is an opportunity through a careful study using our Solar Pathfinder device to understand where the aperture is to the sky and where we want to put the panels. That then drove the design decision for the form of the house. This is what we talk about at Architectural Resource, really letting the design be given by what we're trying to achieve with the home.
This idea of how do you start when you're starting a custom home and you're beginning with nothing? Where do you start? Well, at Architectural Resource, we actually start with a conversation about what will be the mechanical system. How is this house going to be heated and cooled? That then drives so many of the other decisions. Is this going to be an all-electric house? Is this going to be a gas, which we try to avoid? And in this case, because this was going to be an all-electric net zero energy home, we used our Solar Pathfinder to determine the best opportunity for access to the southern sky.
This is what we call long life. We're on the second floor, the loft space of the Pond Hill project, where we have 2 bedrooms. When we think about a high-performance home, we want to think about a concept that we call long life, loose fit. Long life, loose fit addresses the fact that if we put a lot of time, effort, energy, resources, and money into a high-performance home, we really want to leverage that and get the maximum amount of use out of that as possible. It's not a green strategy to create a green home that's going to have a limited lifespan. So when we think about long life, loose fit, we think about how after we celebrate a certain number of birthdays, things like our knees and our hips don't work quite as well as they did when we were younger. If we want to be able to get to the second floor, main floor, and lower level, and stairs are a challenge, we suggest to our clients to consider looking at something called a residential elevator. This allows them to have full access to the house at all stages of their life, independent of what might be going on with their body. This is what we call long life, loose fit, a fundamental sustainable strategy for a high performance home.
So we know that a lot of the conversation is usually around energy, but we're going to be looking at a few other aspects and attributes that we feel are very important in a sustainable home that have nothing to do with energy. And this idea of long life, loose fit, and providing an elevator when it fits in the budget can make sense. We have another strategy, which we call future ready home, which allows us to do something when we don't have the budget for that.
So one of the concepts we like to introduce with all of our projects is the idea of future ready homes. What does that mean? Well, I've already talked to you about how this is primarily a story and a half with a finished lower basement. Should have anything happen to our clients where mobility issues become a concern and they can't navigate the stairs, how will they be able to access their home? I'm actually standing in how we've developed a strategy to make that happen. This is, for now, a closet, but it's been conveniently designed to be modifiable to a future residential elevator. These two laminated veneer lumber plates are designed to carry the track for the elevator. The floor and the ceiling have been designed with isolated framing so that it's not continuous. That allows us to remove the framing in this location and have a full 3-story shaft from the loft to the main floor we're standing all the way down to the basement. And we just call that smart design.
So this idea of being ready, even though you maybe can't necessarily make it happen right now, but having a home that does allow you to take that into account. And I'm going to stop share. I'm going to open up the final project that we're going to be sharing today, which is a home that is in Ann Arbor. It's been designed to be, net zero energy certified. And it has some really special features going on that we're going to share with you here, which we're going to take a look at something called permanent wood foundation.
We're down in the crawl space of the sanctuary at Hope Farms, and it's an opportunity for us to introduce to you the special foundation system that we're using here, called a permanent wood foundation. In many homes, we use concrete block, poured concrete for our foundation walls, and we also use concrete footings. That's fine. The only issue is that concrete is the single most highest embodied carbon and embodied energy product that we're using in our construction today. A permanent wood foundation eliminates that concrete, which has a phenomenal impact on the positive environmental aspect of this home. If you look behind me, you'll notice that there is framing, which is 2x6 framing members at 16 inches on center. On the outside, it has a 3/4 inch plywood sheet. Both of these materials are pressure treated so they can withstand the impact of moisture. Outboard of the plywood is a 10 mil polyethylene sheet which provides a drainage plane for the water, and then outboard of that is a gravel backfill. Underneath the wall framing is a pressure treated footer plate which then sits on a gravel footing that's 12 inches deep. This gravel footing takes the place of the concrete and provides a stable and well-drained foundation for the crawl space, or in some cases, a basement. So using a permanent wood foundation was part of the overall strategy with this project to reduce our embodied carbon impact.
Now, the usual question when we talk about permanent wood foundations is, how long is that going to last? Well, I remind people that Venice is built on a wood foundation. These permanent wood foundation materials have actually been tested up, they've been in place for upwards of 70 years and are continually being tested, and they show no signs of decay or rot. And in fact, the permanent wood foundation specialists that we've worked with suggest that these are 500-year structures. He says that the wood above the foundation will rot before the wood that's in the foundation. So we are excited to be exploring this. We've done it on a few other projects. And I want to share a little different concept of sustainability, which again has nothing to do with energy.
You may not be aware of this, but every year in North America alone, upwards of 1 billion birds lose their lives through impact on glass, such as this. Bird strike is a very important concept in terms of building sustainability, and we want to try to minimize that as much as possible. In this case, because we had all of this glass, and the sanctuary at Hope Farms is on a migratory path, we introduced to the clients the concept of bird glass. Bird glass has a spiderweb pattern in it that's visible to birds, but invisible to us. So our clients can be sitting inside this building, looking through this large portal to nature, participating in nature, but not having a negative impact on that nature. That's the natural advantage that bird glass provides.
And this idea about bird glass and bird strike protection, again, nothing to do with energy, but we're trying to, with this presentation, expand the conversation to, true sustainability. And we have one last thing to share, and we're going to finish right on time, which I'm really excited about. I don't know how we managed to do that with all the interruptions we had, but we're going to talk a little bit about the use of reclaimed materials.
I'm standing in front of the log cabin entry to the sanctuary at Hope Farms, and it's a really good opportunity for us to share with you some of the design decisions that were made regarding the cladding or the skin of this building. We opted to use recycled materials, repurposed, salvaged materials from the 1800s in some cases. This timber is from an 1800s homestead. The tin roof you see came from a tobacco barn. This is reclaimed Doug fir timber that's being used for the siding. All of these materials are helping us reduce our carbon footprint, but they're also bringing the character, the history, the legacy of these materials forward, which makes this really incredibly charming. And what is cooler than a log cabin entry to a high-performance net zero energy ready home?
All right. And with that, I'm going to stop the share and turn it over to Brett and our team. I again apologize for that technical snafu we had in the center there, but we got through the most of the kind of the key things that we wanted to talk about. Brett has sent out to all of you the actual links to these different videos so you can spend more time with them. There's more that we were hoping to cover, but we didn't quite have enough time. But we're just thrilled to be part of the Green Home Institute. This is our first year acting as sponsored. I've enjoyed what Brett has done. He's taught me and my team so much through what he's doing. It's really great to turn around and thank him by being sponsors. And I want to share with you that we are residential design specialists, and we do projects across the country. And we team up with homeowners and builders to really do some special things, as you've seen with these projects. If any of you who are participating in this are interested in talking with us about how we could team up with you and help you serve your clients, we'd be delighted to do so. We also have coming up on the 31st of January at the Sanctuary for Hope Farms a special new home planning event. This is going to be a limited situation, 20 people, 10 couples. We're going to walk you through the key things that you need to be considering when you're doing a high performance home or even a low performance home. So if anyone's in the area and like to participate in that, at the bottom of the document that Brett's going to send you is a link that you can go and learn more and register for that. Or you can go to architectural resource, no S at the end.com, to our events and go to our Creating Home Series tab. So I'm going to turn this over to Brett, and we're going to answer as many questions as we possibly can in the time we have remaining. And thank you. It's been an honor to present to the Green Home Institute audience. This is just stunning.
Yeah, thank you, Michael, and always, thanks for the kind words and taking time to go with us and being our first session of the year here. And before we jump into those questions, just a huge quick thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly 500 members. We're trying to reach 500 by the end of this year, so we have a long time to get there. And all of our sponsors, including Architectural Resource, who are making products and have services to help meet more sustainable goals and more sustainable outcomes. So I saw one of the questions kind of sneak in the chat, so we probably didn't get to it because it gets kind of washed away in there. But the question was, are you going back and monitoring, the energy use to see how your projects, are really faring out as far as usage or cost? And so part of the answer, I will say, the second home you featured, Pleasant, Future Pleasant, we had them on, I don't know, 2 years ago now.
2 years ago,
And
yeah.
so they went through a lot of analysis on that. Now, that was very driven by our members, the Bells, the homeowners, to do that. And so I think the question is, are you all actively saying, hey, how are your bills actually holding up? Are they actually meeting the goals? And are you looking at other things that you monitor besides energy?
Great question, Brett. And the answer is yes, we are. Not all clients are. Harvey Bell, our client, was just outstanding in terms of the technology. Uh, I think we may have learned more from Harvey than he learned from us. So he's been one, but there have been several others who are tracking energy performance. And it's exciting to see that we're actually performing a little better than projected on the projects where they're keeping track of the performance. So the answer is absolutely yes.
Yeah. Um, and again, if your staff want to jump onto and throw in any other questions or things they want to highlight that they saw um, coming up in the chat. Um, I think we were talking about your approach to the exterior rigid insulation and discussing about how you're, you know, anything over 2.5, you're having to use different fasteners and all of that of continuous insulation. So I don't know if you can just kind of get into that a little bit more and talk about, are you exploring other types of insulation besides foam, like wood or rock, mineral wool? And does that change that sort of dynamic of how thick you can really make it?
Okay, great question. So first of all, the basic concept of continuous insulation doesn't prescribe what type of insulation we're using. So Brett, your question is really stellar. In fact, I was going to, the sanctuary at Hope Farms, we actually used continuous insulation as our strategy. I was going to share a segment on that, but we ran into some time constraints. But we used mineral wool, rock wool, 3-inch layer, a single layer, 3-inch of rock wool insulation on that. We would love to use rock wool insulation on every CI project we do for carbon reasons, flammable resistance reasons, drainage reasons, insect and rot resistance, and R value stability. It's an outstanding product, but it's expensive. It's also has been hard to come by. during COVID, we had a couple of different projects where we had spec'd rock wool and we had to come away and use EPS or polyiso. Um, so the answer is yes. The concept is what we like. Because, and I think I've heard the expression before. It's like you put a sweater on, you don't eat the sweater. So you wrap the house in the insulation, and it goes a long way towards defeating thermal bridging. And it's a phenomenal strategy for retrofit situations, DERs, because more often than not, if a house is looking to be renovated, there are issues with siding. We take the siding off, we come back with insulation, we put new siding on. It's a perfect opportunity to really cost effectively address the thermal performance of a wall.
Mhm. And are you seeing, I guess, any
Oh,
pushback from?
let me say one
Go
more
ahead.
thing.
Yeah.
You also asked about wood fiber. Timber HP, who I believe
Yeah.
is a sponsor of the GHI, phenomenal product. We had looked at using Timber HP, I think, on 3 different projects, but budget reared its ugly head and
Sure.
devalue engineering. I liked it rather
Mhm.
than value. Devalue engineering had it sunset those products. Now, what's going to
Mhm.
happen is that as they become more mainstream and they increase their volume, their prices will start coming down. And there will be some projects where it's going to be important to clients to take a look at the carbon component, because that's
Yeah.
for us, when we learned about the carbon component, that was a revelation. I mean, some of the homes, our living building challenge project that we did that Susan worked on, Burbeck at Beacon Springs, if we were to do that project again today, we would do it completely different. Because
Right.
if we took a look at the carbon impact, yeah, we've got a long payback period on the carbon program for that project. So
Right.
what we're looking at, straw bales, straw panels. There's a lot of exciting new uh,
Mm.
mycelium.
Yeah.
There's a lot
Yeah.
of exciting new products coming onto the market, which we're excited to take a look at and see if they're going to make sense for our clients' projects.
I'll add one more too that we looked at and kind of learned a hard lesson with is cork, which sounds like a awesome product, and I'm sure that there are good applications for it. But we looked at an application where it was also the finished surface, so it was the insulation and the finish. And the manufacturer had in all their literature that it's rodent proof and resistant,
Mhm.
but we found that after it's installed, the squirrels still like to get at it. So it's one um, that we wouldn't recommend doing, in at least in our area, in a heavily wooded area.
Yeah, and this points to
Mhm.
we have a mantra at AR that we don't really spec a product with confidence until it's been on the market for 5 years.
Hmm.
And why so? Because a lot of people come to market, make claims, extend 10-year warranties. The company's only 2 years old. I'm sure they mean well. They've probably done accelerated aging and testing products. But until it's gone, we'll explore it. And if a client's interested in doing it, we'll absolutely do it. But the cork folks said, no, birds don't attack it, squirrels don't attack it, insects don't. Not true. At least in
Mhm.
our, and we won't mention anyone's names because they may become
Yeah.
the sponsor for the GHI. So, you know, we don't want to diss anybody, but
We
you want to be careful with all these whiz bang
we
new products that are on the
we
market.
we might get support by our good friends in nature who are hungry, who want to who want us
Yeah.
to have this insulation. Um, well, and I like that thing you mentioned, the 5 years. That kind of reminds me of the term people use, the bleeding edge versus the leading edge, right? You're kind of on the cusp of that somewhere, right in the middle, like wanting to make sure there's some certainty to it, but certainly using innovation. So well, I'm glad you brought up embodied carbon because that was going to be where my next question, and there was a question about that. Certainly you sort of, you seem to be addressing it very prescriptively in the sense of this permanent wood foundation, some other things you had mentioned, the mineral wool, but of course, as you all know, being passive house folks, you're going to be doing energy modeling, right, all day long on these projects to make sure they're on target. But are you starting to look at utilizing embodied carbon modeling to say, you know what, it's not just us using this one product or another, but here's where it is and here's where it could have been and here's the proof of it.
Well, the truth of it is that when we learned we went to the Fine Home Built or JLC Live out in Portland, Oregon about 6 years ago. And there was a speaker there who literally blew our minds and introduced this idea of embodied carbon.
Mhm.
And that is a big part of our focus. What we are doing is we're using various different carbon modeling software. In fact, Trevor can speak to that. On our current Living Building Challenge project, we looked
Mhm.
at several different carbon modeling softwares. Trevor, do you want to speak to that, what we discovered?
Yeah, so we investigated a couple of the different ones that are approved by the Living Building Institute. And what we
Hmm.
kind of landed on was that in terms of material embodied carbon, so I believe that's A3 of the life cycle. That was the beam tool, which is essentially just a really decked out, really well made Google sheet that you fill out and basically give exact measurements on how much of each product. It does a really good job of showing you what your embodied carbon is there, and then putting that in tandem with EC3, which is
Hmm.
advertises serving A3 through A5, being, the product itself, its manufacturing and its transport. Um, we didn't use it for the material itself because Beam was just so thorough in that. We felt like we got a really good number, but for the manufacturing and transport, we found that using EC3 gave us a good piggyback, and we were able to combine these together. Green Home, or I'm sorry, Living Building Institute was all for it as far as I'm aware. So yeah, just using a variety of tools made it really possible for us.
And when you're doing that analysis, do you see conflicts between, I guess, in your
Yes.
energy modeling, saving energy versus saving carbon versus coming in on budget? Are you seeing that? Do you kind
Yes,
of
yes.
play that dynamic out?
All the above. It's this
Yeah.
dance. Well, it's a great question because
Hmm.
it's a sliding scale, and you think about, three graphs that have to cross at the key point because currently addressing carbon does take resources. It's not
Hmm.
going to be your low cost option currently. Now, having
Hmm.
said that, building smaller is your low cost option that addresses energy performance, carbon, sustainability, everything. So we want to try to be careful of just blanket suggesting that everything that's going to be a low carbon solution is going to be more expensive. Good design, building orientation, like we talked about how we looked at the Pond Hill project. So there are so many factors. We just love this stuff because it's really, it requires a fair bit of thinking to make
Hmm.
all this come together. And it'll be different for different clients, Brett. That's the other kind of key driver. So
Yeah.
if budget's a concern, we'll have a palette that we'll be able to use. If planetary impact, sustainability, we have another target. So it's all client driven. But what we love is having the experience, exposure, and knowledge to be able to bring these things to the table and see what's going to make sense for our clients.
Yeah. Now, this other question that came in, now, I think it was actually perhaps even in your project many years ago that introduced me to this technology that can actually have you hit whatever air leakage target you wish to achieve by blowing in the agents, and you can do it with ductwork as well. So the question here is, is that something you're continuing to use? And I always like to frame it in the sense of like, is it something you specify often or use as a contingency? If at the end of the project, air leakage and duct tightness numbers aren't hit, you sort of have it as a contingency backup plan, right? Is that something you're still utilizing?
Yes, and I get it confused if it's aero barrier or aero seal. Team, can you guys help me?
And that one was Arrow Barrier.
Okay, so what Brett's speaking to is a aerosolized caulk that's distributed into the interior space of a home while it's pressurized. So basically, you put a blower door in, you start pumping the air into the house to make it a positive pressure. and then you release these mist heads. It's like sprinklers going off in the house. And this aerosolized caulk is carried through convective means to the holes, the gaps, the cracks. The bigger the hole, the more air, the more it brings the aerosolized product to that area. And you can literally decide what you want your ACH to be, and you just run the misters until you achieve that. As you run the misters, the longer they run, the bill gets higher. So you want to be mindful of that. But we we don't for a new build, we don't use it as our like go-to strategy. We more use it as
Mhm.
our kind of get out of jail free card at the end.
Yeah.
But for instance, on the Bell project, our colleague Jake Lapan from Fireside Home Construction, not using AeroSeal, Aero Barrier, was able to achieve an air leakage rate of 0.23 ACH 50.
Mhm.
So it's not always necessary. It's a great strategy to keep in your back pocket. And if you're in a retrofit situation, it's ideal, particularly if the house, like if someone just bought a new home and they haven't moved into it yet, because
Mhm.
this stuff lands on every horizontal surface. Ask us how we know.
Yeah, yeah. And I know we've got I think a video tour of yours of all where you did that, so somebody can check that out too as well. I think the other question I just want to throw out there is, anyone who's looking to bring someone on for architectural services, for design services, like, can you just speak to, briefly, what kind of that process looks like?
Yeah, great question. So, how we serve folks at Architectural Resource is we like to start with the client's aspirations and goals, and it's going to be different for every client, every project. This is why you were saying, like, which lever do you pull? It's going to
Mhm.
be completely given by whatever the client's goals are. And we help folks with deep energy retrofits. We help people with passive houses, net zero energy homes. We even help people do code minimum homes, but it's going to be a really good code minimum home. And one of the other things we like to do is build a team around our client's project. Typically, how this goes is architects work with their clients all the way through the design process and then put it out on the street, get three bids, pick a builder, and go. That's certainly a strategy, and it can work. It has worked. We can do that. But what we typically recommend is something we call integrated design. And with integrated design, we suggest the idea of bringing the builder in earlier on in the process, ideally right from the very start. And we form a three-legged stool that includes the client, us, and the builder. And we work together to achieve the client's goals with the team. We find if you're doing a high performance home, hands down, this is the best way to approach it. Because not only are we going to be able to be working as a team, but we're going to be learning from our builder. So
Mhm.
Alex is working on a Living Building Challenge project with Paul Abueva from Abueva Builders out in Kalamazoo. He has been just delightful to have on the team all the way through, suggested different ideas, brought different concepts, different materials. We do the same thing with all of our builders. We really respect their opinion, we respect their experience, their knowledge, and their wisdom. And so that would be something that I would suggest. Yeah, and there's Paul. He's on the yeah, he's on the call. That's kind of cool. Yeah, it just if you're building a high performance home, you need to be firing on all cylinders. There's no tolerance for sloppy work, bad execution, or poor design. Everything has to be on its game for that to work out.
Um, yeah, great. And I guess I guess the only other question, and I think you kind of answered it, but just where where does that come into comparison to, like, a design build process, you know what I mean? Like how can you kind of compare
How does
those
it?
two a little bit?
Yeah,
Yeah.
that's a great question. We get actually asked that a fair bit. So design build has the builder and the designer as one entity. The benefit to that is you get this close collaboration. We completely agree that there's a benefit to that. What we do suggest, though, is, and I don't want to be disrespectful to any design builders who are on the call, but having the design and the build under one contract kind of is like having the fox guard the hen house. There's no separation of church and state. It's you don't have any opportunities to really leverage the skill set of someone who's an excellent builder and someone who's an excellent architect or designer, and having them work together. That really gives you the best of both worlds. So again, I want to be careful and be respectful for design build. That's a viable option. Many people appreciate that. What we find is that we can give our clients the design build experience, but we do it with this separation, so we're not both on the same payroll. So the builder could be making suggestions independent of how that might influence the architecture, and the architecture can do the same. At the end of the day, the client wins.
Yeah. Well, great. We're at the end of our time here, and I don't see any other questions. So I guess just as a quick reminder, where can people go to learn more, either get engaged in your visible green home tour on kind of on their own, or come to one of your events, or just reach out to you for further questions?
Great. Yes. So everything would be through our website, architecturalresource.com, no S at the end for resource. And on our website, you can learn more about our mission. You can learn more about some of our projects. On the events page, you can see our various different events that include visible green home tours and this upcoming new home planning seminar. So we encourage you to take a look at that. Reach out to us via the email of mclement, my first name, last name, at architecturalresource.com, or just go to the website and you can get to us through that. But we would be delighted to chat with you about how we could team up with you in whatever fashion, in whatever facility, and help you create something truly amazing with your projects.
Yeah, yeah. Well, Michael, thank you so much, and thanks to your team here, Susan, Dale, Jackson, and Trevor, for attending and helping facilitate the conversation and spending your time with us here today. I really appreciate it. And everyone else, go check them out over at architecturalresource.com. If you're on LinkedIn or Facebook, certainly a lot of great information coming your way, and images that I love to see, and new things that I learn, honestly, following them all the time, something new I have to follow up on and catch up on later. So thank you all so much. Take care. Be well. So bye.
Thank you, Brett.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.